Hello viewers, today I'll show assembly and basic motion of a coil rotor using SolidWorks. First of all, we'll show the assembly of this one. It is consisting of 7 different parts. Let us start assembly. Starting from assembly, it is consisting of 7 different parts. Let us take the parts one by one. This is the bottom part of the main assembly, so we have to take another part of this one. With control and drag, we have selected this component. Now we have to assemble these two. Starting from it, first of all, this central hole should be met with this hole, and we can reverse the direction from here. One constraint is met. We have to satisfy 2 more different constraints. Let us select this hole to be met with this hole. Done. 2 constraints are met. Now the third constraint is required for this assembly. Let us drag this one a little bit up. Now this base part should be meeting with this part. Done. 3 constraints are satisfied. First part is done. Next one, we have to do this radiator part of the motor should be met with this motor and fan together. So this circular part should be meeting with this circular part. First constraint is met. As this one is cylindrical portion, so in this case 2 constraints are enough. Third constraint is not required because we want to rotate this one with respect to bottom radiator. So we want to satisfy only 2 constraints. Third one is not required. Now the second constraint will be actually we have to satisfy the second constraint. Let us meet this one with the bottom of this motor. Done. 2 constraints are met for this assembly. That means this motor can rotate with respect to this radiator. Okay. Next one, what you have to do is this side protector should be aligned at this location. So we are selecting that central hole to be met with this central hole. 1 constraint is met. Next one, the hole. This hole should be meeting with this hole again. Now the third one, that is top of this one, should be meeting with the bottom of this one. 3 constraints are met. So this part is done. Next to that, we have to meet this motor and this radiator together with this flange. Okay. So what can you do is the circular portion of this one should be met with circular portion of this one. 1 constraint is met. Green check. Now the second one also required. For the second one, we can select the bottom part of this one should be meeting with the top part of this motor. That means this part. Done. Green check. 2 constraints are satisfied. Here 2 constraints are required because the motor will be rotating with respect to this one and that one, right? This should be fixed with that main connector. Okay. Done. Next one, we have to assemble this part together with this location. So what can you do is select that whole position that should be made with this hole. 1 constraint is met. Green check. Now the second one, that means this hole should be meeting with this hole. 2 constraints are met. Now the third one is required. That means the faces should be aligned together. So we can take the faces little bit out. That means bottom of this one should be meeting with top of this one. Done. All the 3 constraints are satisfied. Next one, we have to fix that bolt at this location. Now while importing all these components, the first component was this bolt. So as per default practice, the component which one we are bringing first, that is fixed. So we have to make this one float. And also the base part of this one, the central connector, should be fixed. We can make it fixed. Done. Next one, we have to fix that bolt at this location. So we're starting with mate again. Again, the central, this hole should be mating with this cylindrical portion. One constraint is met. Green check. Now the second one is required. That means you have to fix base part of this cylindrical portion should be mating with this portion. Done. In this cylindrical portion, 2 constraints are enough. Green check. It is done. Right? Now what we have to do, we have to select another bolt at this location. So what can we do is we can select another bolt by control and drag. Got another component. Now that to be again mate at this location. So starting with mate. Now this cylindrical portion should be mating at this location. One constraint is met. Green check. Now another constraint is required. We can drag it down and select this face should be mating with the bottom part of this one. Done. Green check. Now all the components of this one is satisfied. Green check. Next to that, what you have to do is you have to combine all these components in one circular array. That can be done using circular component pattern. So let us select the front view and we want to have circular component pattern. So circular component pattern, and with respect to one central location or central axis, you have to make all these patterns. Let us select the central part of the quadrotor, and in this geometry we have got one central axis. This is the central axis. Sketch number 91 we have selected. Now with respect to this central axis, we have to make an array of all these components by 4 numbers with equal spacings. Now select the components to be patterned. First one, the motor radiator, selected. Next one, the motor with the propeller, selected. Next part is this one, bolts, selected. Finally the flange. All the parts have been selected as circular component pattern. Green check. It is done. Let us see whether it is done or not. Yes, all the components have been patterned in a proper way. This is the assembly, right? Let us see whether the propeller is running perfectly or not. Yes, it is running perfectly, right? Now we want to see the basic motion analysis. We don't want to go for any analysis at this moment. We want to see the basic motion of this one, how this propeller will be running and how this total part will be moving vertically up, right? So we want to provide 2 motors. One motor will be controlling all the fans and another motor will be used to have a linear motion of this central part. Okay, starting for the motion analysis. Motion study 1. From here to select the basic motion. Next to that, we provide the motor. We are providing rotary motion. Let us select that motor location. Selected. Let us see the rotation of this one. This will be rotating with 100 RPM. Selected. Now let us calculate this one for 5 seconds. Done. Let's stop it and play it again. So one motor is applied to have a circular motion of this propeller wheel. Next to that, we want to apply one linear motion of this central part. Let us stop this one. Now we want to apply linear motion of this central part. So again, select the motor, select linear motor actuator, and we can select that central part of this one, and the directions to be provided from here. So it will move vertically up, and let us provide a velocity of 0.1 millimeter per second. Green check. Now the thing is, this one is actually fixed, so the linear motion will not be there. So we have to make it float. Initially you can see it will not run. If we start to calculate, it will not move as it is fixed. So the linear motion we cannot see at this moment. To see the linear motion of this central part, we have to float this central part. As it is fixed, it cannot move up. So we'll float this one. Now let us make it float. Now next, let us calculate this one. So we can see some vertical moment of this central part, right? So by the motor we can have linear motion, by the same time circular motion of these propeller blades. Okay. By this way we can have animation of this one also. Let us close this one, and can have a slow motion of this one. Let us have the motion with 0.25 times. So it is showing that the quad rotor is moving vertically up. By the same time, the propeller blades are also rotating with a particular velocity. Now next to that, we can have a video of this one. Let's close this and take a video of this. You can save it in the form of any video format. Let us save this one by the name of assembly2, and we'll save it in MP4 format. While saving this one, the frames per second is, we can select 30 frames per second. It is good with the aspect ratio of 1360 to 305. Let us save this one. It is being saved. Okay, so this is all about our today's video. This is a very basic video. In this video we have shown the assembly of different parts of this quad rotor. By the same time we have shown the basic motion of this one, and in this basic motion we have provided one linear motion and also circular motion of the propeller blades. Okay, thank you.